Again, welcome to College Algebra. In these lectures, we're going to discuss about quadratic functions. So our main objective is to go through the characteristics of a quadratic functions. Also, how to find the vectors of a parabola whose equation is a standard form. We know a quadratic function graph is a parabola form. So again, here we're going to find the vectors of a parabola whose equation is a standard form. Also, we're going to learn how to graph a quadratic function and also how to find the vectors of a parabola whose equation is in general form. Also, we are going to use the quadratic function to solve maximal and minimal problems. So let's start with recognizing the characteristics of a quadratic function. So first, we're going to start with a form of quadratic function, how quadratic function looks like. So here we have f at x equal to ax squared plus bx plus c. Okay, so f at x also can be y. So it's the same as saying y equal to ax squared plus bx plus c. The highest degree of the variable in the quadratic function is 2 squared. So we start with x squared, then we reduce by 1 to x, then c is a constant value. So here we say that a and b and c are real numbers, but a cannot be 0, because if a is 0, then we are going to have a linear function, because the highest degree for the variable will be 1. When the highest degree of a variable of an equation is 1, then we have a linear function, not a quadratic function. Quadratic function, the highest degree of the variable should be 2. So this is an example of a quadratic graph. So as we said, again, they are parabolas. So when a quadratic graph parabola open upward, here the first figure 4-1 is open upward. That means the a value is positive. So again, this graph here, the function is f at x equal to a squared minus 2x minus 3. But our main thing we want to know here is that when a parabola open upward, that means the a value is positive. When a parabola open downward, the a value is negative. So here we can see the function is negative 2x squared minus 8x minus 3. Since the coefficient of x squared is negative value, the parabola is going to open downward. When the x squared coefficient is positive value, the parabola will open upward. So let's recognize the characteristics of a quadratic function here. So first we have an equation of a quadratic function, which is f at x equal to ax squared plus bx plus c. So as we said earlier, a, b, c are real numbers, and a cannot be 0. A must be at least positive or negative value, but not 0. Because as we said, if a is 0, then the quadratic function will turn to linear function, because the highest degree will be 1. When you have a function with highest degree of 1 for the variable, then the function is linear function. When highest degree is 2 for the variables, then we have again a quadratic function. So here we said that if the a value is positive, then the quadratic function parabola will open up. If a value is negative, then it open downward. So example here, we have a quadratic function f at x equal to x squared minus 2x minus 3. So if this is our function, since a is positive value because a squared, a equal to 1, the parabola will open upward. We have another example here, f at x equal to negative 2x squared minus 8x minus 3. Now, since a is negative 2, which means it's less than 0, the parabola will open downward, as we saw in the previous figure 1 and 2. Let's go back. So on my left side, the parabola open upward because A is a positive value. To our right, the parabola open downward because A value is negative or -2. So let's go to the third characteristics. The vertex is the turning point of a parabola. So in our graph here, the vertex will be 1 and -4. That's the turning point of the parabola. The same thing applies to the second equation. The vertex will be -2 and 5. So again, the vertex of a quadratic function is the turning point of the parabola. So as we said, based on this equation, when we graph it, we saw the vertex is 1 and -4. Again, 1 and -4. The second will be -2 and 5. So -2 and 5. Now in next lectures, we're going to learn how to find the vertex, not only by plotting the graph. So here, when we plot the graph, where we see the turning point of the parabola will be our vertex. We can also find the value of it using some formula. So next is the minimum or maximum point occurs at the vertex. Since the A is a positive value and the parabola open upward, then the vertex 1 and -1 will be the minimum or the lowest point on the graph. And we can see the graph here. The first graph on our left, we can see 1 and -4 is the minimum point because that's the lowest point on the graph. Now, if the graph open downward, which means A is negative value, less than 0, then the vertex will be the maximum point, as we can see on the graph on B. -2 and 5 is the maximum point. So here we say -2 and 5 is the maximum or the highest point on the graph. Now the next is the axis of a symmetry. Here we say the axis of a symmetry is the vertical line that intersects the parabola at the vertex. So the parabola will be symmetric about this vertical line. So here the graph of x equal to 1 is the axis of symmetry. As we can see, when x is equal to 1, because that's the point for the vertex. And the axis of symmetry here is when s is -2. So the vertex, the x value gives us the axis of symmetry. The vertex s is 1, so axis of symmetry is 1. Vertex when s is 2, -2, the graph axis of symmetry also is s equal to -2. So again, this is the basic characteristics of a quadratic function. Now next, as we saw earlier, we can find the vertex by plotting the graph and see both where if the graph open upward, then the lowest point. If we open downward, then the highest point is where we can get our vertex. So the vertex will be the turning point. Also here, we're going to find the vertex of a parabola whose equation is in standard form without using a graph. So the standard form of an equation, normally we have f at x equal to a, x minus h all squared plus k. Again, a shouldn't be 0. So this is a parabola with a vertex h and k. The first h here and the k. And the parabola also opens upward because a is a positive value when a is greater than 0. It will open downward when a is less than 0. So the axis of a symmetry of a parabola, again, is the vertical line graph of the equation x equal to h. So let's see an example here. Here they say we should find the vertex of the graph of each quadratic function. So we have f at s equal to 2, x minus 3 squared plus 5. So to find the vertex here, we remember the standard form as we saw it in the previous slide. It will be a times s minus h squared plus k. So h is the value after the s minus, and plus k is the value. So based on the equation here, f at s equal to 2s minus 3 all square plus 5. Our vectors will be 3 and 5 because we're going to have x minus h. So since we have minus there, it means s is positive value. Then plus k. And here we have positive also plus 5. So our vectors will be h equal to 3 and also k equal to 5. So the vertex is 3 and 5. Now the second question, we still write a standard form of the quadratic function, which is f at x equal to s minus h squared plus k. Now the function given was minus 3 s plus 2 all squared minus 4. Remember, x is minus h, not plus h, so we change this to negative. Then plus k is very good. We don't need to change it. Here we have positive, so plus will be negative, negative will be positive. So here we get minus 3x. We want to change positive to negative, so we multiply by negative 2. So negative 2 times negative will give me plus 2, all square. Then we have plus 4, so we want to change here to plus. So if I have plus, then 4 should be negative 4. So minus 3, parenthesis s minus 2 all square plus negative 4. We can see that the vectors will be negative 2 and negative 4. So here we say since h is negative 2 and k is negative 4, the vectors is the point with coordinate of negative 2 and also negative 4. So let's move to the next option, which is graphing a quadratic function. As we said earlier with the linear function, linear, since the line will be very straight, if we are graphing a linear function, the quickest way is to find the x-intercept and y-intercept. X-intercept means when y is 0, what's the value of x? And y-intercept means when s is 0, what's the value of y? Because it's linear. When you get the two lines, you connect them. But since this is a parabola, which is non-linear, we need more than 2 points to get the form of the graph. So the strategy for graphing a quadratic function, first we need to determine whether the parabola opens upward or downward, which means to say that whether a value is negative or positive. Then next, we find the vertex of the parabola, which will be the turning point. Then we find the x-intercept to get 1 point. When y is 0, what's the value of x? Or we find y-intercept also. Then after that, we identify one additional point on the graph. Then we draw a smooth curve through the points, finding steps from 2 to 5. So here we are given a question to graph the quadratic function f at x equal to 2s plus 1 squared minus 8. So the first thing I want to get is the vertex. So we know the standard form will be as minus h all squared plus k. Now a is 2, s plus 1 squared minus 8. So the next step now, we find the vertex of the parabola. So we have again 2s plus 1 squared minus 8. So here the man plus 1 should be minus 1. So it will be minus 1. So this will give us the h value to be minus 1. Then the k value will be minus 8. Now here we said that since h is negative 1, as we can see negative 1s minus negative 1, and k is negative 8, we can see plus k is negative 8. Then we say the vertex point will be negative 1 and negative 8. Now, how do we find the x-intercept? To find x-intercept means when y is 0, what's the value of x? So we substitute f at s to be 0, then we find the x. minus 8 cross the equal sign become plus 8. So that will give us 8 equal to 2s plus 1 all square. Then the 2 will cancel the 8. The 2 will go to 8 is 4. So 4 equal to s plus 1 square. Then we know s plus 1 will be plus or minus 2 because when a square cross equal sign becomes square root. So square root of 4 again is 2. So this means we're going to have s equal to -1 plus or minus 2. So either s will give me 1 or s will give me -3. So we get to s values here. So 1 and 0 and -3 and 0. Now, how do we find the y-intercept? The opposite. Now we say that when s equal to 0, what's the value of y? So that is the y-intercept. So we substitute the s for 0. And we solve the equation 2, 0 plus 1 all square minus 8. So to give us 2, 1 square minus 8, which will still give me 2 minus 8. So our answer here will be -6. So this means again, when s is 0, the value of y is -6. So the y-intercept is the point with coordinates 0 and -6. Now the next step, step 5, we identify one additional point on the graph. And here, because of symmetry, we say the point -2 and -6 is on the graph. Then step 6, we have at least 5 points now. We draw a smooth curve through the point 5 in step 2 up to 5. So this will be our graph. Again, you can see all the values we find is in the graph. So next is how to find the vertex of a parabola whose equation is in the general form. So here we say to graph a quadratic function given in the form f at x equal to as squared plus bs plus c, when a not equal to 0, is called a general form. So the graph of the function is a parabola with the following vectors. So if f at s is as squared plus bs plus c, we can find the vectors to be minus b over 2a, and h will give me c minus b squared divided by 4a. So step 1, again, we are going to graph the graph. So step 1, we're going to determine whether the parabola opens up or down. Now we can see that s squared coefficient is -2. And since it's -2, then it's going to open downward. So we say the equation has the form f at s equal to as squared plus bx plus c. And a is -2, b is -3, and c is 3. And since the value we get will be less than 0, the parabola again will open downward. So next we find the vertex. So x equal to minus b over 2a. We plug in minus b. Remember our function is a and b and c. S squared, the coefficient is b. Then the same thing. Again, the same thing applies to, first we find the vertex here. So we have the value b and a. Then the next step, again, we find so again, we find the vertex x equal to -b of divided by 2a. We know b was 5, then 2 times, again, our function, the a was -2, which we have it, again, we are using the same equation in our previous question. So we can see our a is 2, and we have h, and the k value h is -1, k will be again -8. So we plug in the values. A is -2, B is -5, and C is 3. So here we can find x is minus b over 2a. So we know b is -5, a is -2. We get the vertex to be -5/4. So the x-coordinate of the vertex is -5/4. Now our goal is to find the y. So when we substitute -5/4 into the function, we can find the y value, which gives us 49/8. So our point here will be -5, 4, and 49/8, which will be our vertex. So we can see the vertex, this is open downward. The reason why it's open downward, because again, the a value. So we can just write the smooth. So next we find the s-intercept also. S-intercept means when y equal to 0, we solve the equation, we get s is half and also s is -3. So we are going to get 2s-intercept, half and 0, then -3 and 0. Again, s-intercept means when y equal to 0, so we substitute. Then y-intercept means when y-intercept means when s equal to 0. So s-intercept means when y equal to 0, what's the value of x? And y-intercept means when s is 0, what's the value of y? So here we get 3. So we get y-intercept on 0 and 3. Y 0 and 3, because finding the y-intercept, s is 0. So these are the points now. So we can again draw the line, plot one additional point. Then step C again, we can draw the graph of the function. So that will be the conclusion of these lectures. Again, in these lectures, we learn the basic concept of quadratic function and also the characteristics of a quadratic function. Also, we learn how to find the vectors, also how to graph quadratic function. So again, wish everybody the best and thank you.